we got limited time because in your syllabus they have mentioned limited number of periods for this lesson. Therefore, within that time, as is a fast track course, we try our best to complete this lesson as soon as possible. Okay, therefore, focus carefully and try to get maximum level. Okay, right. The first thing we need to understand in this lesson that we are just using a kind of a number system, and we are learning a number system which is unique for us. Okay, that doesn't mean there are no any other number systems used or using by the people or anymore. Okay. From grade 1 to advanced level in maths, most of the time you used only one number system to count and calculation. Okay, how did you count the stuff like 1 2 3? That's what the teachers and parents taught you to count. But remember, that is only just one way of counting. Okay, something we created, human created, that number system we are using right now. But there are more number systems used by few years ago, maybe 1,000, maybe 2,000, maybe 20,000, 100,000 years ago. People use different number systems. Got it? They didn't count it like 1 2 3. That's what you need to understand. In every calculation you are doing right now, which is relative to the number system you learned from grade 1, which is decimal. Okay, then what is the number system you learned? Is decimal. Right. Then why we are learning number systems, Lama? Because to understand how computer is going to represent data, because it uses a different number system which is binary. Okay, as a human, for counting and calculations we learned decimal number system. It got 10 symbols starting from 0 1 2 3 4 5 6 7 8 9. Right, all the numbers we are using right now got only these 10 symbols. Got it? Then what is the total number of symbols? Total number of symbols will be 10. This is our number system. But in computer, uses only two symbols, which is 0 and 1. The total number of symbols will be 2. The total number of symbols, we used a term called a binary number. Sorry, page number. Then what is the base number of binary number system? 2. Why? It uses total 2 number of symbols. Number of symbols will be 2. Symbols used. Okay. Then why we are using these kind of symbols? You learn maths and you didn't ask these questions from your maths teachers. Why we are using just the symbol for 1? Who created that one? Can't we write number 1 like this, number 2 like this, number 3 like this? This is the standard number, okay? Because everyone should follow a standard method to represent numbers, right? Therefore, everyone agrees and follow these symbols. That will be easy for us to count and communicate, mainly for communication purpose. Got it? They are just symbols. If you understand this one from the beginning, it will be easy, right? These are just symbols. If you want, you can create a new number system with different symbols. Yes, you can. Okay, but the problem is others are going to accept it or not. Think about, you're going to live in a different country, um, uh, a different type of people. They don't know anything. They don't know how to count. They don't use any number system. Then you can introduce a new number system. Okay, a long time ago, people used some kind of stones to count stuff, count the animals in their farms. They didn't have any number system. Then they use something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is also a number system. The Roman number system: 1, 2, 3, 4. Another number system. Okay, but we are not going to discuss those number systems in this lesson, because we are going to learn something related to ICT, computing stuff. Therefore, we learned 4 number systems which will help us to use in future. You know the relationship between binary and decimal, right? And importance of learning them. What is the importance of learning binary and decimal? Decimal is for us humans, and it will be helpful to communicate with computer by learning binary, because everything inside the computer represents in binary. Got it? Prashanth, you got a network issue, right? I am recording the class. Yes. All good, Lamai? Then you know the purpose of these two, the reason why we need to learn. We need to represent our numbers inside the computer, and also we need to take the stuff inside the computer to our number system. Okay, right. Can you hear me? Right. If something happens to the network, just let me know. If you can't hear me clearly, it's lagging, just let me know. Right. Then what are the other two number systems we are learning in this lesson? Octal and hexadecimal. Octal and hexadecimal. The reason why we use octal and hexadecimal, because we're going to use these two number system to represent some stuff we are going to learn in future, right? Some numbers we has to represent in hexadecimal because it will be convenient for us to represent those numbers in hexadecimal. For example, IP addresses, then the address that we use to identify each and every computer in internet, right? Right. Therefore, we use different numbers, different number systems, because it will be helpful for us to do some stuff in future, right? Octal number system uses 8 symbols, 8 total number of symbols. Then it should start from 0. Then you know the end number. The last number should be 7. Okay. What's the reason? Because there should be total of 8 symbols. In order to make it 8 symbols, we must finish it at 7. Okay. Then what are the other symbols? 1, 2, 3, 4, 5, 6. Decimal number system, total number of symbols are 10. Then that is why the last number is 9. Because we are starting from 0. Hexadecimal, there should be a total of 16 symbols. Then we should start from 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, it is A. Why is that? Because after 9, the next number should be a new symbol. Because there should be 16 different symbols. No? In hexadecimal, there should be 16 symbols. Those 16 symbols should be different each other, unique each other. Then we can't write 1 0 because we already used them here. Okay. The next symbol is A. A represents what? Yes, number 10. Right. A represents the next number, which is 10. But we can't write like 1 0. It should be a different number, different symbol. That is why they introduce a symbol called A, because everybody familiar the alphabet in English. Okay, it's easier for them to use ABCD other than a completely different symbol. Right. B means 11, C means 12, D means 13, E means 14, F means 15. Then you know the last symbol should be before the base number. Okay, therefore last symbol will be 15, which is F. The last symbol should be just before the base number 9, just before the base number 7, just before the base number 1. Clear? This is the mandatory stuff you should know. Raise your hand if you are okay up to this point. If you got any questions, ask. Okay, right, done. Just clearly understand the stuff, because we have to do this stuff fast, and if you missed anything, it will affect to the other stuff we're going to discuss later. This lesson is something like continuation. You should know these things to understand the stuff we're going to do next, not like the previous lesson. Lesson number 2, something different. If you absent 1 week, yes, you can catch the stuff next week, but this lesson is not like that. The more, almost all the lessons we conduct from this week, it's completely different. That means it's a continuation, and you got a good chance, because once you miss the class, all the recordings are going to upload to the LMS. You can watch them anytime. No one will miss any classes. Even though you miss, you can catch the stuff, right? And we assign you lots of works, including tutorials and all the stuff. Hopefully you have done all the tutorials from lesson number 1 and 2. You have to upload them into Google Classroom. Once we complete this lesson, all the stuff questions, reviews, assessments, papers, everything need to upload to the Google Classroom. Okay, that's how we're going to assess them. Right. Then Lamai, the next thing you need to understand. We'll learn about decimal number system a bit because everybody knows about that. Decimal number system. Okay. For example, I'm going to take one question, one number, which is 152. In this lesson, Lamai, as we are dealing with different number systems, we have to identify each and every number uniquely. Therefore, we use the base number to represent every number. Okay, even though it's decimal number, we have to put base 10. Right, 152 base 10 is the example number we're going to take. And how this number represents using weighting factors. If you write this number using weighting factors, it will be like this: 1, 5, 2. This number 2 represents just 2 units. Okay, that means it is something we need to multiply it by 2 to the power 10 to the power 0 times 2 is 2. 5 represents the tens, means 10 to the power 1. 10 times 5 is 50. You already know these things, but I'm writing with weighting factor. Okay, 150. 5 represents 50, not just unit 5. Okay, this 1 represents hundreds, 10 to the power 2. 100 times 1 is 100. Got it? By combining these numbers, you can make 152. Then this number 1, the value of number 1 is 100. Right? I'm explaining these things. I know you already know that. Okay. This knowledge can be applied to all the number systems. That's why I'm explaining again. Got it? Right. Then Lamai, how are you going to represent this number in a counting frame? That is my next question. This one also you did in grade maybe 2, maybe 3. Okay, I know that, but I'm going to teach it again because this knowledge is helpful. Right. How are you going to represent Lamai? Listen carefully. Don't think there's nothing in here. There's very important stuff you need to understand. Just wait and have a look. Okay. Right. This is decimal number system. Okay. Then you need to represent the first count represents like units, ones. Next tens. Next hundreds. Next thousands. You know that. How number 1 unit represents the weighting factors will be 10 to the powers 10 to the power 1, 2, 3, and so on. Okay, you can continue. There'll be no end. Then how are you going to represent this number 152? Then you represent them with circles. 2 represents 2 circles. 1, 2. 5 represents 5 circles. 3, 4, 5. Okay. 1 represents 1. Clear? Now listen carefully. This is how we're going to represent this number. Is clear? Okay. What I'm going to do is I'm going to keep filling units here. 3, 4. I'm going to add, right? I'm going to add one by one. Let's think about some kind of fruit. 1, 2, 2 apples, 3 apples, 4. Likewise, I'm going to add them. I'm going to count them. It should be represent, right? If it is a number system, you should be able to represent any number. Right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the maximum number we can represent in this one. You know that. Then how are you going to add another one? How are you going to add another one? Let's say I'm going to add this one here. And there are 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. Can we keep these 10 units here? No. Then what is the next thing we can do? We can keep them here. Therefore, now is the screen something like vibrating? Right. Don't worry. Now we can't keep them. What I'm going to do is I'm going to take all the stuff, take all 10 units and take them to the next position, right? We are going to do the same thing in other number systems, because maximum number of the units we can put is 9. If there are 10, including that extra unit, and we take them to the next position, all units, then what happens? Then we have to remove all of them. We have to take them to the next position as a one unit. Then this one red color circle represents how many units am I? 10. Got it? 10. 10 is there. Right. Now, if you got any questions, ask. Okay. Then this extra one represents 10. Clear up to this point? Right. Then what I'm going to do is you need to apply same knowledge to the binary number system. But we got 2 here now. I'm going to draw it like that. Right. My next number system is binary. It's better if you can note it down everything, the important stuff. Right. Lamai, represent this number, this binary number, like 10111 in a counting frame. Represent this binary number in a counting frame. Start. Right. Then how to represent this number in a counting frame? It's a binary number. Okay. Now everybody knows how to represent a decimal number in a counting frame, which is okay. Great. I'll try to copy and paste it here. Right. Then what are the changes you need to make to represent a binary number? We can't represent these numbers. We have to represent something like 10 to the power, sorry, 2 to the powers. In decimal, we use 10 to the power 0, 1, 10 to the power 2, something like that. Here we use 2 to the power, 2 to the power 0, 2 to the power 1. Okay. And what are the values of the 1, 2, 4, 8, and etc. Okay. But it's same scenario. We are using 10 to the powers because the base number is 10 in decimal. We use 2 to the powers because the base number of binary is 2. Right. How to represent this number? We need an additional bar here, which represents 16 to the power 4. It's easy. What is the maximum number of circles that we can put into one bar in binary? Is 1. 1, 1 circle, no circles, 1. This is how we're going to represent. Clear? Easy. Now think about if we want to add 1 to this binary number, or what is the next number of this binary number? How are we going to represent that? This is the point. That is why I explained decimal number here. How we're going to add 1 to this number. Can you add another 0 here? Yes, you can, but you can't represent in this counting frame because it's binary. The maximum number we can represent is 1. If you want to add 1, what is the next solution, Lamar? You have to take these two numbers to the next position. Okay. Because next position is 2's position. We can take 2 circles into next position, then it will become 1 circle. And you need to remove these 2. Got it? Then can you keep these 2 circles in this bar? No. Then you have to take these 2 circles into next position. Then you have to draw another one. Then you can delete these 2. Can you keep these 2 circles? No, maximum is 1. Then this fourth position, there are two circles. The actual value of these two circles is 8 because this is fourth position, 2 to the power 2. Then you need to take these two circles, which is 8, to the next position, which represents 8. Then we can keep it one circle. The value is 8 now. Then you can remove these two. Can we represent this number? Yes, which is okay. Then what is the final number you got here? How are you going to represent this number in counting frame as a binary number? 1, 1, 2 zeros, 2 circles are there. Other 3 zeros, nothing. Okay. That means when you add another 1 to this number, okay, the answer you will get is this one. Got it? You don't need to learn how to add in this way. We're going to do the binary number addition later, but try to understand the concept here. Okay, how binary numbers behave. Exactly similar to the here decimal. Maximum number of circles that we can put is 9. 10th one, we need to take all 10 circles into the next position because that is 10th position. When you fill with 10 circles here, the actual value of 10 circles in this bar is 10 times 10, 100. Then you can remove all 10 circles and put it to the next position as one circle because in this position, one circle represents 100, which is equal to 10 times here. Similarly, 2 circles here means 2 ones equal to 1, 2 position. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. Got it? Right. Now, next, similarly, I'm going to represent next two number systems in this way. Right. Let's represent the next number system, which is octal. Right. I'm going to take the example number, which is 2, 6, 7. Base 8. Why base 8? Because we are considering octal now. Right. Similar to the previous question, what I'm going to do is I'm going to represent this number in a counting frame like this. Right. I'm going to copy and paste it here. Then what are the changes you need to make? Suppose this one is an octal number system. Instead of 10 to the powers, what should be the element? Eight to the power, because base number is 8. 8 over 0, 1, 2, 3, which is equal to 1, 8, 64 times 8, whatever the values comes here. Okay. Right. Then how you can represent this number? 2, 6, 7 is you need to put 7 circles there. 2, 3, 4, 5, 6, 7. Can we represent 7 circles in a one bar in octal number system? Yes, we can. Do you remember the table we mentioned here? Octal number system, the last symbol is 7. Yes, we can represent 7 circles in a one bar. Okay. Decimal 9, binary 1. Right. Therefore, we can represent 7 and 6 circles comes here, and 2. Right. Then what is the value of these 2 circles here? 2 times 64. What are the values of 7 circles in here? 1 times 7, just 7. 6 circles here, 8 times 6. Right. Then how are you going to add another one? We're going to add lemma. Can we keep 8 circles here? No. 8th position is next position. You can keep all 8 circles as one circle here because it represents 8. You have to remove these 8. Right. Then how many circles are there? 1, 2, 3, 4, 5, 6, 7. Can you keep 7 here? Yes, it is possible. Then what is the answer lemma? In here your answer is 2, 7. And you need to represent this one as a 0 because there's nothing. There's 8. Okay. After 2, 6, 7, the next number in octal number system is 270, not 268, because 8 is not a symbol in octal. Did you get it? Okay. This is important. Right. Similarly, we're going to do the same thing for hexadecimal. Clearly understand lemma. It will be much more easier for you to do calculations in this lesson easily if you got this one. Right. My first example for hexadecimal number system is 2, 1, take 2, 0, 2, 0, F, base 16. What is F lemma in hexadecimal number system? We mentioned here. F means 15. The value of F is 15. but that is not 1 5, just 15. Okay, think about there are 15 circles. And how you going to represent this one, Lama? Right, I'm going to copy the same counting frame to here. What are the changes we need to make? I'm going to empty the counting frame with different values. What are the place values? It will be 16 to the power 0, 16 to the power 1, 16 to the power 2, 16 to the power 3. Values, just calculate and put it. 1, 16, 16 times 16, just put the value there. Right. Then Lamai, how are we going to represent this number? Rukuni is missing right today. Right. Right. 16 to the power 2 means 16 times 16, which is 256, right? Then 256 times 2. Okay, put the value there. How to represent this number? 20F in hexadecimal. What is the maximum number of circles that we can put into one circle? Is 15. Okay, total number of symbols or numbers we can represent is 15. 1 5. F means 15. Okay, value of F is 16. That means you can draw 15. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Hope it's correct. Next number is 0. Don't put anything here. 2, 1, 2. Value of these two circles are equal to 256 times 2. Got it? Right. Then I am going to add another one in hexadecimal. And I'm going to get the answer. Can you add another one into this bar? No, it will be 16. We can't represent 16 symbols. 16 can be represented in next bar because it's 16th place. This one circle represents 16 here. Okay. Then you have to take all these 16 circles next position, which is equal to one circle in here. Right, then how are you going to represent the answer, Lama? This answer is 2, 1, 0, base 16. There's nothing. If you want, you can put 0. Okay, then what is the addition? What is the value of 20F plus 1 will be 2, 1, 0, base 16. Okay, by looking at these two values and the answer, maybe you can't get an idea. That is why I drew this one counting frame and explain. Okay, then you can get how these number systems are going to act. Clear? Then all four number systems work in a similar way, right? But you didn't know the decimal number system are the way the decimal number system behaves is equal to all the other number system. Once you got the concept, it will be much more easy for you to do the calculation. Okay. Right. You have to make a nice note later, or maybe while I'm doing this session. Okay. The next point we're going to do is we need to learn number system conversions. Right before that, we need to identify how these numbers weighting factors work. Right. Here we learned 152 represents like 10 to the power 0, 10 to the power 1, 10 to the power 2. You have to multiply and get the value. Then how this number represents in binary? How this binary number represents in that way? 1, 0, 1, 1, 1. These numbers represents the weighting factors will be 2 to the power 0, 2 to the power 1, 2 to the power 2, right. These are the place values. Get it? Okay. Just for now, that's enough. These are the values these binary numbers represent. Then how this octal number represents? Similar way. I'm going to take this number 2, 6, 7 base 8. These numbers represents like the powers. These are the place values. Okay. Uh, 8, 1, 2. Got it? These are the values of these numbers in octal. When you multiply, you will get kind of decimal values. We'll talk about it later. And how the place values weighting factors of hexadecimal numbers similar. Right, I'm going to represent this number here 20F A16 numbers represents. We did the same thing in counting frame. Okay, there's nothing new here. Right, clear. Got it. Then we'll come back to decimal number system, and I'm going to show you the stuff you learn in grade 1 again. What is that? Decimal addition. Okay. Listen carefully. Okay. Don't think this is something you already know. Yes, you already know, but you should understand the concept behind it, because in grade 1, grade 2, grade 3, you didn't learn this one correctly. That is why you can't apply the same knowledge to the other number system. You learn one number system, the actual way that number system behaves, you should be able to do any calculations in binary, octal, and hexadecimal. But right now you can't do that. Right. How decimal addition works? Right, we'll take one example. The first question is 172 plus 951. How are you going to add these two numbers? Get the concept? Same concept we are going to apply to other three number systems. Right, 3 plus 1, sorry, 2 plus 1 is 3. Can you represent number 3 in decimal number system? Yes, that is within the symbol range. Then you can put the maximum number of circles you can put is 9. Remember? Right, then 7 plus 5 is 12. Can you represent 12 circles in one bar? No. Then you have to take how many? From 12, you have to take the next position is 10th position. You have to take 10s to the next position. From 12, you're going to take 10 because base number is 10 and we need to move 10 to the next position. Remain is 2. We are not taking 1, we are taking 10s and it will become 1 because next place is 10. Got it? Then 9 plus 1 plus 1, again it's 11. 11 we can't represent, we take 10 to the next position, 1 remains. That 1 comes to the next position. Now you're going to get the answer in base 10 because both the numbers are in base 10. Clear? Right. Now we have come to the point, which is binary addition. Right. Same concept I'm going to apply to binary addition as well. My first example is 1 0 1 0 1 1 0 1. Both the numbers are in base 2. Right. How are you going to find the answer? Do you remember the way we add 1 to this binary number? If you got 2 circles, we take those 2 circles into next position as a 1 circle, right? And we can remove those 2 because it goes 2's into the next position. Decimal 10, right? 0 plus 1, right? 0 means there's nothing. When you add something, again something means 1. We can represent 1, no problem. But 1 plus 1 is 2, okay? Can you represent 2 in this position? No. Then how much you can take into the next position? 2. You can't take 1. You have to take 2. How much remains? Nothing. Okay. Then that 2 circles represents in next question as 1. 1 plus 0 plus 0 is 1 is possible. Maximum number we can represent in binary is 1, not 2. Again, 1 plus 1 is 2. We take that 2 into next position as a 1 circle. 0 remains, but 1 comes here. Then what is the thing you need to remember in binary number system? If there is more than 1, take 2 circles into next position. It will become 1. If you are taking 4 circles into next position, it will become 2. If you are taking 6 circles into next position, it will become 3. Got it? Easy answer. My second question: 1 0 1 0 0. Wait, 1 0 1. How to add these two numbers in binary? 0 plus 1 is 1. 1 plus 0 is 1. No problem. 0 plus 1 is 1. 1 plus nothing is 1. No issues. We can represent this number. Got it? Problem occurs when the maximum number exceed in a number system. We have to take the number of base number into next position. Question number 3: 1 0 1 1 0 1 1 1. Right. Try adding these two numbers and send me the answers to the Zoom chat. Right. Send me your answers. Right. How you gonna get the answers? Like 1 0 1 plus 0 is 1. No problem. 1 plus 1 2. We can't represent 2. We have to take 2 into an expression. It will become 1. Okay. When you take these two ones into an expression, it remains 0. Again, this place total become 2. Then these two ones are going to take into next position, it will become 1. Always next position, 1 circle represents 2 circles in the previous position. Okay, in binary. Decimal it's 10, octal it's 8, hexadecimal it's 16. That's why I told you, same concept. The numbers we move left to right is going to change according to number system, but everything behaves in a similar way. Right, remain 0. Now you got 3 ones here. Now you got 3 ones here. Can you take all 3 into next position? No. Okay, because next position always 1 circle represents 2 circles in the previous. Therefore, first you have to take 2. Then it will become 1 in this next position. Remains 1. Okay, because there are 3, total is 3 now. When you take 2 to the next position, remain 1, but you can represent 1 here. Remaining 1, you can keep it. Okay, then 1 plus nothing is 1. Got it, Laman? There's another way we can do the addition. It's something like, without understanding the concept, right? When we doing lots of calculations, right? I will teach that method. For now, try to understand the concept now. Okay, right? Question number 4. Try this one. This time 3 binary numbers. Once you got the concept, Lamai, it doesn't matter how many numbers you got, how how big the number you got, it doesn't matter, right? You will get the answer. Right, there are 3 ones. Then the number of ones that we can take to next position is always 2. Can be 2, 4, like that. Once we take 2 into next position, it will become 1, remains 1. Again, there are 3, then we can take 2, it will become 1, remains 1. Right, we're going to take these 2 ones to the next position. We're going to write the remaining one there. Now we got 1 0 0 0. You can represent 1. 1 plus 1 is 2. Then put 0 and 1. 1. Got it? Right. That is binary addition. Okay. Now we are going to do the next addition, which is octal. Write the topic. First example. Now first tell me, is this number valid in octal? Is this a valid number in octal? No, because we can't represent number 8 in octal. The largest number we can represent is 7. Okay. Right, I'm going to add 137 base 8 plus 203 base 8. How you're going to add these two numbers and get the octal number? Easy. This time you have to take what, Lama? Maximum number is 7. When you reach 8, you have to take all 8 circles to the next position, then it will become 1. Okay, 8, octal 8. Now 7 plus 3 is 10, but we can take how many to the next position? Just 8. How much remains? Element remaining 2. Got it? Then 8 circles, it will become 1 circle in the next question. Right, 3 plus 1. Do you remember the counting frame? Noctil. What we just did here, we got 7 here. We put 7 circles. Plus 1, it will become 8. Then all 8 circles we bring next into next position as a 1 circle. That is why this 6 became 7 here. Right. The lemma 3 plus 1 plus 0 is 4. We can represent 4 in octal number system, no problem. 2 plus 1 is 3. Yes, it is possible. Then addition of these two octal numbers will be 3, 4, 2 base 8. Easy. Okay. What is the thing you need to keep in mind when you do addition of any two numbers in any number system? You need to worry about the maximum number of numbers we can represent, or the base number. You can't reach the base number or the last number just before the base number. Okay, right, next number 2056. Both the numbers are octal. Okay, base 8. Then your answer should be base 8 as well. Right, 6 plus 2 is 8. We can't keep 8. We have to take those 8 to the next question as a 1 circle. 1 point. Remain 0. 5 plus 1 is 6, plus 4 is 10. Take 8 to next as 1. Remains 2. Because total is 10. Take 8. Remains 2. 3 plus 4 plus 1 is 4. Okay. 6 plus 2 is 8. 0, 1. Goes 8. Goes to the next position. Clear? Right. Third question homework. Write the question and complete it as a homework. The next topic, hexadecimal addition, and we are done for today. Okay, then you need to complete the questions in the tutorial, plus we are conducting the quiz today. Okay, just from these number systems and addition. My lesson number 1, 2 tutorials should be there in class Google Classroom. Unit number 1, 2, we just completed unit 2 last week. You must submit tutorials. I'm going to check next week. Okay, hexadecimal addition. We still did any conversions yet. Okay, next week I'm gonna start all the number system conversions, binary to decimal, decimal to binary, and all the stuff. Today just having kind of familiarizing all the number systems. The best way is doing calculations like addition. Right, first question, the first hexadecimal number will be A5 base 16. You need to add 1 4 base 16. Do the addition lemma. Remember, what is the maximum number of units we can put into hexadecimal? Is 16. You can put up to 15. When you reach 16, you have to take all 16 circles into next position as a one circle, because next position represents circle 16, right? 16 represent one circle. When you reach 16 times 16, you have to take all 16 times 16 into next position as 2 5 6. One circle in this position represents 2 5 6 2. Okay, right, same concept we apply everywhere. 5 plus 4 is 9. Is 9 a symbol in a hexadecimal number system? Yes. Can you represent as it is? Yes, no problem. 9. A means 10. 10 plus 1 is 11. Can you represent 11 directly in a hexadecimal number system? Yes. 11 means what, Lamai? 10, 11, 12, 13, 14, 15. Always write this one, even though when you're doing exam, in a real exam, write it. Don't try to waste your thinking power by memorizing or analyzing those stuff. Write it and refer this one. A means 10 plus 1 is 11 means B. Just write B. Base 16. Easy. Question number 2. 4 9 6 7. Both base 16. Do the addition. Get the value. 9 plus 7. What is 9 plus 7? 16. Can you represent 16? Is there any symbol for number 16? No. The maximum number of circles you can put also 16. Then you can take 16 to the next position as a one circle. Remain 0. 4 plus 6, 10 plus 1 is 11. Yes, you can represent 11, which is as B. B0 is the answer. Question number 3. E, C, B, A. 2, 3, 4, 5. Addition. Both the numbers are base 16. What are the numbers for E is? Refer this one. 14. C, 12. B, 1. A, 10. Right. Do the addition. And remember, the base number is 16. You have to take 16 into next position as 1. 10 plus 5 is 15. Can you represent 15? Yes. As what, Lamai? E. Sorry, F. 15 is the last symbol F. 11 plus 4 also kind of 15. Okay, F. If you are finished, send me the answers. 12 plus 3 is 15. Okay, 15 means what, Lama? Here, F. You can represent 50. 14 plus 2, 16. Can you represent 16? No. You have to take how much? 16 as well. Remains 0. When you take 16 in the next position, it will become 1. This is the answer. Okay. Got it? Delamai. Matrix is stuff. Right? All the number systems plus addition of all the number between number systems. Okay. These are the stuff we learned today. And I will send you some matrix questions tutorials as well. Right, let's try the quiz now. Let me go through these questions again. Okay, matrix a lot. Write any number in any number system, represent them in counting frames, and do the addition. Also try subtraction as well. Right, we'll do a small quiz today from number systems. There are some questions which include from some general stuff. Storage units like bits, byte, kilobytes, megabytes, and all this stuff. Right. This is the quiz. Join the quiz, Lamar. Any questions? Next week, we're going to do lots of questions. Okay. Keep doing questions. Therefore, just familiar everything we did today. Right. Join the quiz quickly. Right, Lamai. Some student having some network issues. Therefore, I'm gonna end the Zoom meeting now. Just continue the quiz till the end. Next week, right? For sure, just go through everything we did so far. Otherwise, you won't be able to do the stuff, continue the stuff. Okay, and don't miss any classes. If you're noticing someone is missing continuous classes and someone is trying to watch just videos through website, right? Then I have to take some action. Okay, you must attend live classes. Yes, I uploaded all the recorded to the LMS and all the stuff. Probably you can get the tutor as well. But just try to attend live classes. Okay, right, Lamai. Then I will end the Zoom meeting. We'll continue the class next week. Continue the quiz, don't stop. Bye, Lamai.